All right, so we're going to talk about gases and the kinetic molecular theory. The kinetic molecular theory describes the behavior of gases in terms of motion. This theory is divided into 5 postulates, which also describe how we can derive the laws that we come to now create the gas laws. Okay, and how they behave. All right, so they have 5 postulates. Let's go through each one. The first one says that gases do not repel or attract each other. Actually, that we know is actually not the case. Intermolecular forces actually do exist within gas particles. The hydrogen bonding, the dipole-dipole interactions, and the London dispersion forces actually do take place within gases, but they're so weak and so negligible that we're actually going to say we're going to ignore them. And the reason we're going to actually now call all these 4 postulates come from and make up what we call ideal cases, ideal scenarios. Okay, so ideally, we're going to say we're ignoring the fact that they have IMFs. The second postulate we're going to talk about is that gas particles have no volume. Again, we know that's not true. So I'm going to put an NT by these 2. Not true. Gas particles do have volume, but it's extremely negligible compared to the volume of the actual thing that holds it. So again, we're going to completely ignore it, saying that gas particles have no volume. It just makes calculations easier. We're going to put this under an ideal situation, an ideal gas. The third one states that gas particles are in constant random motion. That's true. They're always moving around. They're always bouncing off things. They're always going in straight lines until they actually veer off. But that is true. Gas particles are constantly in motion. They never stop moving. The fourth one is that no kinetic energy, we're going to call kinetic energy KE, you might see that in class, is lost when particles collide with each other with the walls of the container. That's true. When particles, when they're moving and they hit something, they're actually what we call elastic collisions, meaning that they do not lose any kinetic energy, and kinetic energy is saved within that collision, whether it's within another gas particle or at the walls of the container. They are elastic collisions. The last one we say is all gas particles have the same kinetic energy at a given temperature. Temperature is a measurement of kinetic energy, and when we measure the temperature, we're measuring that kinetic energy of those particles. So that's actually very true. So when we're talking about the kinetic molecular theory, the first 2 are assumptions, or making them say that we're talking about an ideal situation, because those things are very small, the IMFs and the volume. But everything else is true no matter what gas we're talking about in all scenarios. So the behavior of gases are based on 4 main factors. They're based on the volume of the container that they're in, the pressure that is on the container within those gas particles, the amount of gas particles that we're talking about, and the last one is the temperature. And we want to make sure when we're dealing with gas particles that a temperature, when we're talking about calculations, is always in Kelvin. Why do we care about that? Because Kelvin is never ever negative, and we don't want to deal with negative values. When working with gases. Okay, so those 5 postulates make up the kinetic molecular theory.